Hi everyone, thanks for joining me in this video where I'll be covering the scalability benefit of the cloud. This will be in the context of supporting you to pass your AZ-900 Azure Fundamentals Certification exam. In this short video, I'll give you an overview of scalability, specifically vertical and horizontal scalability. So let's get into it. To start off with, what is scalability? According to documentation from Microsoft, scalability refers to the ability to adjust resources to meet demand. To add some additional detail to this, a scalable system should be able to accommodate growth and increase demands by adding more resources such as CPU, RAM, or additional machines, without negatively impacting its performance or availability. Scalability is important in IT because as businesses grow, they typically require more computing resources to support their operations. If a system is not scalable, it can lead to issues such as slow response times, system crashes, and decreased productivity. Therefore, scalability is an important consideration when designing and deploying IT solutions, particularly those that are expected to handle a large amount of data or volume over time. In this video, I'll cover off two types of scaling. The first one is vertical scaling. Vertical scaling, also known as scaling up or scaling vertically, refers to the process of increasing the capacity of a single server or hardware component to handle more work, traffic, or data. This is typically done by adding more resources such as CPU, RAM, or storage to the existing server or component. So one example when you could scale vertically would be if a web application experiences an increase in traffic. A vertically scalable solution may involve upgrading the existing server by adding more CPU cores, RAM, or storage. This can increase the server's capacity to handle more requests and maintain performance under heavy loads. Vertical scaling is often a good solution for smaller systems or applications that have lower resource requirements. However, it has some limitations. It can become expensive and impractical to continue adding resources to a single server. Additionally, there is a limit to the amount of RAM and CPU you can add. Another way to scale to meet demand would be via horizontal scaling. Horizontal scaling, also known as scaling out or scaling horizontally, refers to the process of adding more servers or hardware components to a system to handle more work, traffic, or data. This is achieved by distributing the workload across multiple machines, each of which can handle a portion of the workload. So in the same example I discussed earlier, if the web application experiences an increase in traffic, a horizontally scalable solution would involve adding more servers to the existing infrastructure. This can increase the capacity of the system to handle more requests and maintain performance under heavy loads. Horizontal scaling is often a good solution for larger systems or applications that require high availability, fault tolerance, and the ability to handle large number of requests or users. It can provide better scalability and resilience compared to vertical scaling, because it can handle larger workloads, and it does this by distributing the workload across multiple servers. Additionally, it can be more cost-effective as it allows for the use of widely available hardware rather than relying on expensive, high-end servers. There are some disadvantages of horizontal scaling as well. It introduces complexity in terms of managing the distributed system and ensuring that data is consistent across all nodes. This requires the use of technologies such as load balancing, distributed caching, and database replication. So now let's touch on elasticity. With vertical scaling, you can scale up or scale down. You scale up to increase capacity, and you scale down to decrease capacity. With horizontal scaling, you can scale out or you can scale in. Scaling out would be adding additional resources, while scaling in would be removing resources. You shouldn't confuse scalability with elasticity, even though they're often used interchangeably. Elasticity refers to the ability of a system to dynamically adjust its resource usage to meet changing demands. This includes both vertical and horizontal scaling, in response to changes in workload, traffic, or data. An elastic system is able to quickly and automatically allocate or deallocate resources as needed, without human intervention. Elasticity can be achieved by using cloud computing technologies like Azure. So just to summarize, scalability is the process of adding or removing resources, but elasticity is being able to do this automatically without manual intervention. So that's the end of this video. Hopefully you should now understand the scalability benefit of the cloud. Don't forget to like and subscribe to the channel for more content like this. Thanks for watching.